For this model, we're gonna use Max 2009 with the polyboost. And the first thing we're gonna do is to create a plane and to map on top of it our current piece of concept art. This is pretty straightforward. We just apply the UV mapping modifier on top of it. And plane material, we're gonna assign the map. And here's our piece of concept art. This is gonna be useful, of course, because we are gonna try to trace as much as possible the concept art with our 3D modeling. So let's start with something quite easy, like the helmet, which is not really gonna impact the overall proportions of the character. Just place a sphere in order to match more or less the shape of the helmet below, and just convert it to a editable poly and delete the lower part because we don't need it. And we are also going to delete half of it because we are gonna apply symmetry later. Just try to match our piece of geometry even on the side view. Basically the idea is to trace the concept art below, so little bit of rotation, and now we are gonna try to just do a quick topology change in this lower part, extrude the lower edge, and now in vertex mode with soft selection activated, we are slowly trying to pull and push vertexes to match the shape of the helmet below. As you can see, I opened the rollout of the polyboost of the loop tools, and we are gonna extensively use the set flow and flow connect features. These are really useful when you want to simply adapt the existing loops or just to insert new loops and keep the continuity of the surface. It's really great. It's way better than the simple connect of the editable poly. So we'll keep like extruding edges and moving vertices with the soft selection activated, trying to match the concept art below. Working on only one side and then on the other side, which in this case is the front. It doesn't have to be super accurate, but at least we are trying to get the overall feeling of this helmet. It's time to apply a symmetry modifier. So everything we do on one side is going to be replicated on the other side. Just add a loop to have a much more of a hard edge in that area. Just add a more loop with the flow connect feature, the polyboost, so we can keep the continuity of the surface. And now let's try to keep the topology as much as quad as possible to have a nice smoothing when later we are going to apply the turbo smooth. Few optimization where is needed. Just a few cuts. Set flow, as you can see, is used really a lot in my workflow. It's a really great polymodeling tool. Now just try to relax a little bit that area. Maybe it was not even necessary. Let's apply a gray shaded material, helps to visualize better maybe what's going on. So here we have the general shape of the helmet, and so let's apply a quick shell modifier to give it a little bit of thickness, and just add a few loops with the chamfer just to have some hard edges below. Loop insertion, chamfer on the edge of the lower part, and now let's do the spike. We're gonna cut this polygon, and I use the geopoly function. Here's better positioning. We're gonna use the geopoly function of polyboost to convert a generic n-sided polygon into a kind of circular polygon, as you can see. And we're gonna do a few extrusion right now and scaling just to try to get this kind of spike. Inset. As you can see, we always try to keep quad topology as much as possible. It's really important for continuity and smoothness of the surface when we are going to apply turbo smooth later. Just relax the tip of the spike a little bit, the soft selection activated, and the relax of the editable poly. Quite easy. Here we are. Just select and detach the new created faces and just cap the lower part. So now we have our helmet as a piece without hole. So we have now two separate pieces like the spike and the helmet, and just create the base of the spike with a few extrusions. Now let's do a preview of the Turbo Smooth, and I'm gonna fix this problem of topology, removing that vertexes which was causing a kind of not smooth surfacing. So just a little bit of tweaking with the set flow, and an edge insertion to have a stronger hard edge on the base of the helmet. And now with the flow connect, just try to have a better topology in terms of radius of the polygons on the spike. Here we are. This is pretty much it about the helmet itself at this stage.